Dear students, today I am going to discuss Digital Signal Processing Laboratory experiment number 4. The title of the experiment is Circular Convolution of the Given Sequence. Circular convolution of the given sequence, the aim is, here we are going to perform circular convolution. Okay, so the aim of the experiment is to perform the circular convolution of given sequences using convolution summation formula, matrix method, linear convolution from circulation with zero padding using simulation software MATLAB. Now this experiment I am going to conduct the simulation using MATLAB. So I will show the practical demonstration video now.
Return in MATLAB. So already we have returned the MATLAB. Using this particular command, you are going to write the program. Here CLC clear screen, clear all, whatever at the back end, it will clear all the sequence, all the codes performs whatever it previously it will be cleared. And here you are going to take the two input sequence. The input sequence are named as X and H. Input your first sequence is named as H, X, and the input second sequence is named as H. So the input is taken using the command called input. Next, now we need to take the length of the sequence in variables. So the length of X sequence is taken as N1 and the length of H sequence is taken as N2. So to identify the length of the sequence, you are going to use the command called length of X, length of H. We need to identify what is the maximum length of the sequence among these two inputs. To identify that, we are going to write the statement n is equal to max of n1 comma n2. Now x is equal to x comma, that input sequence x is equal to x, it starts with 0, 1, 2, 3 like that. Same thing for the second sequence also. Now here we are going to use a for loop. Why? Because in the theory we have stated that it will be a continuous shift from one timings to other timings. So for m is equal to 1 to n, m starts with 0. For n is equal to 1 to n, I is equal to m minus n plus 1, I less than or equal to 0, I is equal to n plus 1. First you have to display your first sequence. So the first sequence is displayed in row 1 column 1. Here second sequence is displayed in row 2 column 2 and it is taken from H. So the convolute sequence is displayed as Y. So here you are going to use it by using convolution summation formula and matrix method. N is equal to 0 to n minus 1. So n will be the number of sequences. Subplot 3, 1, 1 means, so your screen is divided into 3 rows and in that first column, that is first part as a first graph, it will be stem of x. Stem of x means x is your first sequence. Whatever sequence, for example, if you are giving it as 1, 2, 3, 4, then it will be drawn it as a stem. Stem in the sense at a particular time it will start for a particular magnitude. It reflects like a discrete signal and the title is given as a first sequence. Y label is Y. We have x-axis and y-axis. X-axis is labeled as time axis and y-axis is labeled as signal axis. Same thing you are going to draw for the second sequence also. So in your 3 rows, first row will be occupied with your first sequence and the second row will be occupied with your second sequence. So among these 3 rows, in the second place it is going to be occupied with your second sequence. Give the title as second sequence and then name the x-axis and y-axis as time and y-axis label as signal. So in the subplot you have to view the convolute sequence. The convolute sequence title is given using title and for the same convolute sequence y-axis is labeled as signal and the x-axis is labeled as time. So after entering the program in the MATLAB, you have to use this run symbol to run the command. So when you run the command, you have to go to the command window. It will ask for the input and first sequence. So if you input the first sequence as 1, 2, 3, 4, it could be anything. It will ask for the second sequence, input the second sequence, same 1, 2, 3. So when you give the signal over here and input first sequence 1, 2, 3, 4, input second sequence 1, 2, 3, 4, 5. After giving these two inputs should be given in the command window. It will reflect X, H. X is your first sequence naming, H is your second sequence naming, and the convolute sequence is represented as Y, 35, 35, 30, 20, 30. All this process has been written in the program. When you look at the waveform, it is the first signal representation. As we told, like 3 rows. In that first column, second column, third column. So it has to represent your first sequence, second sequence, and convolute sequence. So your first sequence, we are given 1, 2, 3, 4 in the form of a stem signal. It should be represented. So at time t is equal to 1 second, it will be reflecting with magnitude 1. At t is equal to 2, it will be reflecting with the magnitude 2. At t is equal to 3, it will be reflecting with magnitude 3. Likewise, you can continue for n number of sequences. Second sequence, if you take 1, 2, 3, 4, 5, the stem plot is given, and this plot looks like your discrete signal, and the convolute plot is shown over here.
So this is the data which we have entered in the command window. So this enter the first sequence, enter the second sequence which we have given in the program while simulating. After entering the sequence, we will get the convolved sequence 26, 28, 26, 28. Here the length of the sequence n1 and the length of the sequence n2 both are same. So both sequence length will be same, so no need to append zeros. Then we can do the circular convolution between these two sequence x and h. So after convolving, you will get y equal to 26, 28, 26, 20. Now this is the output which we simulated, that we got in the simulation time. First sequence, second sequence, and the convolved sequence. Now the result is thus the circular convolution of the given sequence using convolution summation formula, matrix method, linear convolution from circular convolution with zero padding is simulated in MATLAB, and the output is verified. Thank you, students.